fun math stories, how to calculate luck. Well, today we're celebrating Chinese New Year, so Happy New Year, everybody. Usually we wish each other good luck for the upcoming year on Chinese New Year because everybody wants luck. You see, in ancient China, there was even a book called the Book of Change, or Yi-Jing. It was supposedly to predict your future and to predict your luck. This all started from the concept of Taoism. Taoism says that the limitless produces the delimited, and the delimited has two forms, yin and yang. Yin and yang together, by using a specific arrangement, can create four phenomena. Lesser yin, greater yin, also known as the moon, lesser yang, and greater yang, also known as the sun. The four phenomena produce the 8 trigrams. This is also called Yi-Jing Ba-Gua. If we add another layer of the 8 trigrams, we'll have 8 upon 8, or 64 hexagrams. These 64 hexagrams could be used with the Book of Change to predict your luck and your future. Where's the math? Isn't this supposed to be a math class? The first person to really study this as a mathematician was Godfrey Lebanese. Godfrey found out that the 64 hexagrams was actually just a 6-slot position binary system, with each position either being yin or yang. From a mathematical perspective, 2 to the power of 6 equals 64, resulting in the 64 hexagrams. When Godfrey found this out, he was so excited, he sent a letter to the Chinese emperor saying, "Hey, I found a yin and yang system. Would you like to become Christian now and believe in Jesus?" Now, we don't have all the time in the world to talk about how Yi-Jing predicts your future, but the underlying yin and yang is very similar to another way people use to decide their future, flipping a coin. For example, let's find out the chance of only getting heads when you flip a coin. When you flip a coin once, you only have 2 different outcomes, heads or tails, and only one of them has heads, so it's a 1 out of 2 chance. If you flip a coin twice, you have 4 different outcomes, and only 1 outcome has both heads, so you have a 1 out of 4 chance. And when you flip a coin 4 times, you have a 1 out of 16 chance of only getting heads. Studying luck always involves uncertain outcomes. This uses permutation and combination. Lead the way for studying of probability. Well, who relies on luck the most? It's gamblers. One such story concerns Antoine Gombaud, a French aristocrat who loved to bet on dice throws. So Antoine made a game. The game's rules was like this. You roll the dice 4 times. If you see a 6, you win, but if you don't see a 6, you lose. Using Antoine's experience, he found out that he won more times than he lost. This game wasn't that attractive, so Gombaud made a second game. In this second game, you roll a pair of dice, and in order to win, you need to roll a pair of 6s. Gombaud thought he needed to make the second game proportional to the first game so he could keep winning. All he had to do was increase the number of rolls to 24 times. And if he rolled it 24 times, he should still be winning. So Antoine bet on himself winning, but he actually ended up keep losing. Antoine asked his best friends, who happened to be one of the greatest mathematicians at the time, Pierre de Fermat and Pascal, to take a look at this problem. And they found out that in the first game, when you rolled 1 dice, you had a 1 out of 6 chance of seeing a 6 and a 5 out of 6 chance of not seeing a 6. When you rolled it 4 times, the chance of not seeing a 6 would be 5 over 6 to the power of 4. The opposite of that, of at least seeing 1 6, it would be 1 minus 5 over 6 to the power of 4, or 0.517. So he had a more than 50% chance of winning in the first game. In the second game, the chance of seeing the pair of 6s would be 1 over 36. And the chance of not seeing the pair of 6s would be 35 over 36. If you throw the pair of dice 24 times, the chances of not seeing a pair of 6s is actually 35 over 36 to the power of 24, or a 0.51% chance of losing. This means you lose more times than you win. That's why when Gombaud changed to the second game, he actually started losing instead of winning. Another situation that involves luck and probability is cards. Card games like Solitaire or Texas Hold have a specific ranking of the 5 cards that you can be dealt, with Royal Flush being the highest. Everybody wants to get a Royal Flush because it basically means an instant win. But what's actually the probability of getting Royal Flush? So let's first find out the number of different outcomes if you get 5 cards. There's around 2.6 million different combinations. You can only get 4 Royal Flushes out of the 2.6 million outcomes because there's only 4 different suits, and each suit can only have 1 Royal Flush. So the probability of getting a Royal Flush is 4 out of 2.6 million, which is really, really low. Let's try another example, but instead this time we'll try to find the probability of a full house. A full house is when you have a triplet and a pair. First, let's find the total outcomes of getting a triplet. To do so, we first get the value, which is choose one of the 13, or just 13 different outcomes. Secondly, to choose a suit, we just choose 3 out of 4, or 4 different outcomes for a suit. Then, we need to find the number of total outcomes for the pair. Since we already chose a value for the triplet, we'll only have 12 different values to choose for the pair, or 12 different outcomes. Secondly, we need to choose the suit for the pair, so choose 2 out of 4, which is 6 different outcomes. Since this is a 2-step process, we need to multiply the number of total outcomes of the pair and the number of total outcomes for the triplet to get the final result, which is 3,744 over about 2.6 million, or a 0.144% of getting a full house every time you play the game. This is still a low number, but it's still a lot bigger than the probability of getting a Royal Flush. So that's why people get full houses more than they get Royal Flushes. You see, whether you're finding your luck by using Yi-Jing, dice throws, or even card games, it's all using math. It's not just God's wheel or bad omens, but you can actually calculate it using math and logic. Remember, if you like this video, feel free to subscribe. It helps out a ton.